Ever pondered upon the silence of the cosmos? Why, in a universe so vast we haven't heard from any extraterrestrial life? It's a question that has tickled the minds of astronomers, physicists, and thinkers alike. Imagine the sheer size of our universe, with billions of galaxies each teeming with millions of stars. Around these stars, planets orbit, countless worlds spinning in the inky blackness. With such astronomical numbers, the odds of life existing elsewhere seem remarkably high. Yet here we are, seemingly alone in this vast cosmic ocean. No interstellar hellos, no extragalactic postcards, no cosmic neighbors dropping by for a cup of tea. This profound silence, this deafening absence of contact is both perplexing and intriguing. Is life a rare gem in the universe, or are we just not listening in the right way? Or perhaps the cosmos is teeming with life, but we're yet to make the right connection. This cosmic conundrum is what we call the Fermi Paradox. The Fermi Paradox, named after Italian physicist Enrico Fermi, poses a simple yet baffling question. Imagine a cosmic game of hide-and-seek, and we're it. We're in the middle of an astronomical playground that's roughly 93 billion light-years in diameter with an estimated 2 trillion galaxies. Each galaxy is a kaleidoscopic swirl of billions, if not trillions, of stars. Many of these stellar hosts, like our Sun, likely cradle planets. Some of these planets could be just the right distance from their star, with just the right conditions to harbor life. With such a grand cosmic playground, the probability of life existing elsewhere in the universe seems high, almost a given. That's where the Drake equation comes in, which we'll explore in the next scene. But let's stick to Fermi for now. Despite these astronomical odds favoring extraterrestrial life, we've yet to make contact or find compelling evidence of other cosmic inhabitants. This stark contradiction is the crux of the Fermi Paradox. Enrico Fermi, an Italian physicist, famously posed this paradox during a casual lunchtime conversation. Fermi wasn't the first to ponder the existence of extraterrestrial life, but his name became associated with this cosmic conundrum. He reasoned that if there are a multitude of technologically advanced civilizations in the galaxy, it would take only a few million years for one of them to colonize the Milky Way. Even if we're talking about a relatively slow pace of exploration, say, at about the speed of currently known spacecraft. Yet, here we are, gazing at the stars, listening to the cosmic silence and pondering that befuddling question. Given the age and vastness of the universe, the apparent abundance of habitable planets and the laws of probability, why haven't we detected or been contacted by extraterrestrial civilizations? The Fermi Paradox isn't a paradox in the traditional sense of a logical contradiction. Instead, it's a tension between our expectations based on probabilities and the reality of our cosmic solitude. So, in a cosmos teeming with potential life, where is everyone? Before we dive deeper, let's understand the Drake equation, which fuels the Fermi Paradox. The Drake equation, formulated by astrophysicist Frank Drake in 1961, is a scientific formula used to estimate the number of advanced civilizations in the Milky Way galaxy. It multiplies together 7 factors: the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, the fraction of planets where life actually develops, the fraction of life that evolves into intelligent beings, the length of time such civilizations release detectable signals into space, and lastly, the fraction of civilizations that develop technology that releases detectable signs of their existence into space. This equation, though speculative, gives us a probability range that suggests there could be anywhere from a handful to millions of civilizations in our galaxy alone. Yet despite these staggering numbers, our universe remains eerily quiet. One unnerving answer to Fermi's question is the concept of the Great Filter. Imagine the universe as a vast cosmic obstacle course, and scattered throughout are these filters. Catastrophic events or stages so difficult to overcome that they halt the progression of civilizations. The Great Filter theory suggests such an event or series of events exists, and it's so severe that it prevents civilizations from colonizing the universe. It's a sobering thought, isn't it? This looming, insurmountable hurdle that extinguishes the flame of progress just as it's starting to burn bright. But what could these filters be? Some speculate that it could be the leap from non-living matter to simple life. Others propose that it's the jump from simple life to the complex multicellular organisms we are familiar with. Yet others argue that it's the transition from primitive civilizations, like ours, to advanced ones capable of colonizing other planets. The nature of the Great Filter is still a mystery, shrouded in the fog of our understanding. It's as elusive as the answer to Fermi's paradox itself. While we grapple with these questions, we must confront an unnerving implication. If we find evidence of life, especially complex life, elsewhere in our universe, it could mean that the Great Filter is not behind us but ahead. This would suggest that we, as a civilization, still have our greatest challenges to face. It's a chilling thought, but it's one that forces us to reflect on our place in the universe and our responsibility to our species. On the other hand, if we find that we are alone, it could mean that we've already passed the Great Filter, that we've hurdled over the cosmic obstacles that have kept the universe silent. In either case, the concept of the Great Filter gives us a fresh lens through which to view our existence, our progress, and our future. It's a concept that compels us to question, to explore, and to strive for understanding. Could we have already passed this filter, or is it looming in our future? The answer to this cosmic question remains as elusive as the stars themselves. Another intriguing answer could be the zoo hypothesis. Now, this theory takes a different spin on things. Rather than us being alone in the cosmos, or us being the first advanced civilization, it suggests that we're being deliberately left alone. You heard that right, folks. The zoo hypothesis proposes that higher extraterrestrial civilizations exist and they're aware of our existence, but choose to observe us from a distance, much like we observe animals in a zoo. Picture this: an advanced alien civilization, light years ahead of us in technology and understanding, watching our planet as we watch a fishbowl. They've mastered interstellar travel, they've harnessed the power of stars, and they've transcended the physical limitations that bind us. They've seen our wars, our triumphs, our failures, and our potential. Yet they've chosen to remain silent, observing us from the cosmic sidelines. But why would they do this? The most common explanation is protection, both theirs and ours. They might wish to prevent cultural contamination, much as anthropologists today strive to protect indigenous tribes from modern influences. Alternatively, they might be shielding us from the dangers of advanced technology that we're not ready to handle. Or perhaps they're waiting for us to reach a certain level of technological or social maturity before they initiate contact. There's also the idea of the Prime Directive, a concept from the Star Trek universe. This rule prohibits interference with the development of less advanced civilizations. Could an equivalent cosmic law be in place, enforced by advanced alien civilizations? Of course, this is all speculation. The zoo hypothesis, much like the Fermi Paradox itself, is an unproven theory, yet it's a fascinating idea that forces us to reevaluate our place in the universe. Are we truly alone, or are we being watched? Are we the masters of our own destiny, or are we mere exhibits in a galactic zoo? Are we in fact an intergalactic spectacle? As we continue to gaze at the stars and search for answers, we may one day find out. Despite these theories, the search for extraterrestrial life continues. The quest to answer the cosmic question, are we alone, is not deterred by the complexities of the Fermi Paradox, the intricacies of the Drake equation, the potential hurdles of the Great Filter, or the implications of the zoo hypothesis. Instead, these theories serve to fuel the fire of curiosity and exploration. In this relentless pursuit, humanity has embarked on projects of unprecedented scale and ambition. The search for extraterrestrial intelligence, or SETI, is one such endeavor. Operating under the premise that intelligent life, if it exists, might be broadcasting signals into the cosmos, SETI listens. It listens with an array of telescopes, scanning the skies for signals that might reveal the existence of technologically advanced civilizations. But we're not just listening. We're also looking. The Kepler Space Telescope, named after the renowned astronomer Johannes Kepler, is tasked with finding planets that orbit stars beyond our solar system. It's not just searching for any planets, but those that might be similar to Earth, those that reside in the habitable zone where conditions might be just right for life to exist. The Kepler mission has already discovered thousands of these exoplanets, some of which have tantalizing potential. While we cannot yet confirm if these worlds host life, each discovery brings us one step closer to answering the question that has puzzled humans for centuries. Yet, despite these ambitious projects and the relentless pursuit of scientists around the globe, we've yet to find definitive evidence of extraterrestrial life. But this doesn't mean we stop searching. Quite the contrary, it only makes us more determined. The universe is a vast mystery, waiting for us to unlock its secrets. As we continue our cosmic journey, the question remains, where is everyone?